Hello everyone. I'm here to share my excitement and kind of a mini experiment that I was able to conduct using a platform approach. As you all know that how the excitement of AI started with development of AI, which led to the next frenzy, which was deployment of AI. But the new kid on the block is how you monitor it after you deploy. And plus, if you have a clinically deployed solution, the things become very difficult. For example, I have an algorithm already deployed in my system. I did all the regulatory, legal, IT things. How can I look at a new science in the book? So this was our work recently that we did. We compared the algorithms for the same use case using the platform approach. So it was a coronary artery calcium scoring algorithm. And there are three of them now which are FDA-approved in the market that we were able to compare using the platform approach. And I don't have to buy all three of them. So again, testing the running engine means you already have made a commercial decision and you want to look at other new science coming in the block. So without further ado, we all know that there are always these algorithms which are producing some decision making outputs. Like coronary artery calcium detection is one of them, right? And the downstream therapy of the patient is contingent on that score as well. So it's the stakes are high. Already people feel that the numerical score is not that important, but the categorization is there. And you have FDA approved, and now you have three FDA approved technologies whom to trust. So you have to compare all three of them in your local environment to make sense out of it. So that is the real time validation, and the platforms allow you to try it before you actually make that commercial decision. But the train already left the station for our institution because I made my commercial decision. I have a calcium score algorithm which is as beautifully integrated as you can get. You can see that there's an algorithm which works on the picture. The output comes into AI finding column, and ultimately the report is also pre-populated with the AI report. So the integration starts from the picture to empowering the radiologist, and ultimately the complete report with the descriptors already published. So this is the integration which I cannot afford to lose, but what is visible to radiologists but is not visible to the rest of the hospital, because if I don't agree with these squiggly lines, the clinician should not take a decision unless I tell them to. So it empowers the radiologist as well. But the next kind of the story was, I have the algorithm, but somebody told me there are two more algorithms in the market. So now I'm stuck, like how should I validate my algorithm with a new kid on the block? And they were raving their AUCs again in the high 90s or something. So we devised an experiment using the CARPL platform. I'm not sure how they were able to secure the other AI algorithms, but I had the algorithm C deployed already. B and A, which are also FDA approved algorithms, they had the licenses for that, and both the vendors allowed us to compare all the three algorithms. I had the result on C in my house. There were three AI tools, and the ground truth was a true kind of a calcium score on a gated scale. So we ran it on 44 patients, and we got the mean scores that are gated is the ground truth, 314. You can see A is underestimating, B is very close but overestimating, C is our algorithm which is slightly underestimating or something, right? But we were able to look at their performance side by side. We even have the confusion matrices. If you look at that, this is a very simple way of understanding the output of AI on any research paper that you read. Look along the diagonal. You want the darkest colors here to show the maximum concordance. You can see that in this category, in C algorithm, our deployed algorithm is working very well on the none and the mild. But the new algorithm that we tested using the platform is actually performing better in this category. You can get a snapshot here. And the A algorithm, which we don't have, is working very light blue here, which tells us the winner is this one. Ours is a close second, and the third kid on the block is third. Right. So we were able to get that information on the fly using the platform approach. Otherwise, if I want to do that experiment, I have to first go to the second vendor, ask that, oh, can you give me your FDA-approved technology? They'll say no. Or conversely, if I have to give them the data, my hospital will say, where are you sending your data? So there's nothing that can work around it. When you have a validated platform in-house, My job is to just load the data, run 3 algorithms in the live environment, and then trying to see in my running engine, is my algorithm up to the mark in the market? We are not up to the decision making, but it gives me assurance that mine might not be the winner, but it is good enough for my clinical practice. So your commercial decision can be influenced even after you have made your commercial decision. So the try and buy strategy is important, but testing a running engine becomes more important as we are deploying more and more algorithms. And FDA has 4 pneumothorax AI algorithms, two or three nodule algorithms, 3 of CAC algorithms. So the platform approach actually lets you see the results on the fly. That's even cherry on the top. I don't have to even run the stats on my Excel sheets as I used to do that. All the algorithms and the thresholding can be done, which is the best sweet spot for your algorithm, right? And again, switching the AI becomes very simple once you go through the platform approach. So again, if you are really trying to compare 3 algorithms, whether you made a commercial decision or not, I don't see any other way other than a platform approach to compare them. I think I just wanted to keep it short and sweet, and I'm happy to take any questions. Thank you.
Given the sensitivity of the different algorithms, is there ever a reason, maybe not in this particular area, that you can see an environment having one algorithm for one type of patient and another algorithm for another device? This is Philips, this is Siemens, So would you see the opportunity for more than one of the same target but multiple vendors?
This is a fantastic question. I can tell you currently as well, we have 2 vendors working on the pneumothorax even in our system, because one was legacy vendor and then the new platform approach came, both offer pneumothorax. Similarly, endotracheal tube is second one, brain, LVO, the vessel occlusion is the third one. So we have currently 2 vendors doing the same thing. So I think we will conduct those kind of experiments and then make a decision what will be the widespread dissemination. We have a 21 plus hospital system. It's not a single hospital where you will say, oh, I launched this thing. So half of the people are using one algorithm, half is the other one. I think it can be used inter-vendor, even if they are deployed here, the same principle applies for that as well. I think that will become easier for us, because here the platform approach is based on 2 clinically deployed solutions. Here it was 1 clinically deployed and 2 were, I heard about them. Right. And one of the vendor B, which was not on their platform, I said, I want to compare B. So they reached out to that vendor B, brought onto their platform, and we did the comparison. So again, my heavy lifting reduced. So I'm a researcher, I explore AI tools. It was my curiosity to see that I made a decision a year back, and it tells me my decision was semi-correct, if not, it's not completely correct. So you can extrapolate it to X number of algorithms.
Thank you. Quick question. I really like the concept that you brought up with the try before buy and clinicians, asking the question, is this good enough for my specific clinical data? Do you guys ever think about the data that the AI models were trained on, as well as the radiologists that are involved in labeling that data, and how that might stack up to the clinical data, like the actual use case, as well as like the clinicians that use those AI models? Maybe in terms of skill levels of the annotators that label that data versus the clinicians that use those AI models.
So your question is the fine print behind how the algorithm was trained.
Yes.
Let me step back a year back. When I had to deploy this first algorithm C, although we also contributed to the data 3 years back when they were not FDA approved, but ultimately I compared the algorithm in my local environment again, using my local ground truth. At that time I did not have C and A. It was a very simple exercise, only C algorithm. Vendor said, let's deploy it. I said, I have the ground truth data. It was working fine. I have no comparison B or A at that time. They were not FDA approved. So I don't care the fine print who annotated it. If it works in my system, I'm happy, because the performance is important to me. I checked all the literature, like how they got FDA approved in the first step a year back when I was only testing my choice. That's how I made the choice. But now people are talking about, oh, we got FDA approval last month. Then what is the option with me to make a change or keep the existing algorithm, since I can pay for any algorithm?
That makes sense, like especially when every AI model's been FDA approved,
Yep.
finding a way to
Yeah.
compare how it's been trained with what it's going to be deployed into.
And again, FDA
That
itself gives
connection.
you a guidance. Don't trust us, our approval. Please test in your local environment. It's written front and center. They said like, oh, don't trust us, your local environment. For example, nodule detection. I live in Ohio Valley region where there are so many calcified granulomas that can spoil the party for any algorithm. So if I have not validated in my local practice, FDA approval does not mean anything because it was not trained in Ohio. That algorithm was trained from Vietnam, Australia, India, and part of US. So again, that is something, it's a very valid question. But you have to test in your local environment. No matter you're in Alaska, you're in Ohio, California, every patient population, scanners, pixel density, everything changes.
It's
Rather
always
than
about
me
the
going
testing,
into the
yeah.
fine print, I'll see where the rubber meets the road, it does my job.
Got it. Thank you.